Okay, go ahead. Draw for me what you'd like to.
Just draw the entire thing. So I have a semicircle, and then so we have our big square here. And we have our small square here.
And that's 16.
60 to 16. And we know this big square side length, so we know this is true. That the big square side length is double the small square.
Oh, interesting. Okay,
so if we can solve it from here, and if we can get 64 again, we'll have at least we can think that our hypothesis is true.
Okay.
Although I'm not too sure how we can solve it from here, because we need to find, say, the center's there.
Center.
So we need to find out how we can find the side lengths, which is kind of a tricky problem. Let's see. It's like we don't know how far over the square is from here, so that's kind of the issue.
Good point. Yeah, we don't know how far the square is from where.
We don't know how far this has moved from the center.
Okay. All right, good. So that's one unknown. So what maybe could you call that?
So that's gonna be this distance. Let's call that x.
Okay.
We don't know the square side length, so I'm gonna call that 2y.
Okay.
So, and this is 2y minus x right here.
Yeah.
These are y. And then this is here. The 8 minus y minus x.
Yeah, let's not over-label things.
Okay, maybe we're not going to do that.
Okay. So here we have identified what our unknowns are. Okay.
Well, we can relate x and y in a couple different ways. Probably maybe the easiest way could be just drawing this triangle in. This is the center, we know this is 8. So we have an equation kind of relating y and x.
Okay.
But it's going to be a pretty complicated equation.
Well, what is the equation?
So it's 64 equals 2y squared plus 2y minus x squared.
All right.
Well, that might be useful because maybe we can use this equation and solve for the areas without having to find anything.
Okay, so that's an interesting question. What area are we trying to find?
So we're trying to find the area of the two squares, and we want that to equal 64.
All right. Can you tell me what the area of the two squares is?
It's, let's see, so it's 5y squared.
Okay.
So we have it equaling 2y squared plus y squared. It's a big square plus little square.
Well, but see, we don't know that this is true. We don't know that this that's the area of the combined squares.
This is the area.
Okay. But that tells us that we don't need to know what y is. We just need to follow for what 5y squared is.
Or we could, if we could prove that y squared and 2y minus x are the same, or x equals y.
Okay. Ah, very interesting. So good observation. If you could prove that x equals y here. Sorry. No, that's right. Right.
Yeah.
We were looking for x equals y. Okay.
So how could we go about doing that? Well, if we knew some angles, which we don't, that could help us.
Yeah, it's too bad we don't know the angles.
Because of this, we would have a 1 to root 5. But we don't know much about that. So can we prove that y equals x somehow?
What do you think? What do you think we're going to need to do here?
So we're going to need. We need to find some similarity between y and x.
All right, let me hear some ideas from you. What do you think? Do you think we can prove that y equals x just from this equation all by itself?
It doesn't look like that because we have just variables and integers, and we don't really have like any. We could try to get rid of some variables, like we try to get rid of y and just isolate y.
Okay, so what's the problem though? What's the problem with trying to solve for y? Just to isolate y in this equation?
Well, there's no real way to get rid of the x squared.
Okay, so the fundamental problem is, do you know what it is?
We've got too many variables.